This content is brought to you by BEC Financial Technologies, developing and operating IT for Danish banks.
Please give Paweł a big applause. Thank you.
Hello, everyone. Thank you for joining the last presentation of the day. As has been mentioned, I will be talking about the application based on AI agents. I will also present a short demo to show how this kind of applications is working. Shortly about me, I'm been involved in data analytics for 10 years now. Mainly, I'm a data science domain lead at SoftwareOne, but I'm also involved in the educational as data science trainer and lecturer. My today's topic about AI agent, I will be focusing on one specific framework, which is LangChain, but everything which I will say can be easily implemented also using other frameworks for agents like API assistants from Azure. The LangChain is the environment which consists of several models, agents, chains, tools, and so on, and I will shortly describe all of it. So the titles agent are the LLMs models that are able to autonomously decide on the action that should be taken. This can be, for instance, based on the query from the user, to decide to ask to query the database or query the API or query the documents. So it will be able to ingest, to take the data which will be necessary for answering the question. Very similar are also the chains. Chains can be interpreted as very similar to ETL processes. So this is that we are doing all the steps one after another. So in agent we have the few functions which can be which are decided simultaneously, and in chains we decide which action should be taken in what hierarchy. Of course, in the LangChain we have also the large language models. We also have the tools, because if we want to, for instance, connect to the database, we would have to have the tools to connect to it, or the document loader, so we can also parse split the documents that will be loaded into the system. But LangChain is not only this agent chains and tools, but also the overall environment in which we can also serve the models and also observe and monitor our applications. So we have also LangServe, which is the deployments package, in which we can we can serve chains or agents as REST APIs. And we have also Langsmith, which will also be part of the of my demo, in which we can monitor, debug, seeing the cost of each query, of each answer of the model. So this is the main part of the LangChain environment. Okay. So I'm going to the application that I want to present and talk a little bit more about. This is the application of I would call it the tourist information application, because we can ask about the questions about the weather in specific cities, about the sightseeing in the cities, about the population, in which country the specific city is lying, and so on and so on. So as you can see, we have, of course, the image which has been also generated, by the way, by Azure OpenAI. And we have asked a question about, I'm going on a trip to Barcelona this weekend. What will be the weather be like there? And so we have the information from the bot about the wind, about the number of hours of sun, about the temperature, the minimum temperature, the maximum temperature, and so on. And of course, there is information that all of the weather forecasts can change at any time. So be prepared for also checking it nearer to your travel. Other example about what to do in Barcelona over the weekend. So we have the information about the sightseeing in Barcelona. And of course, this kind of information, especially the sightseeing, can be ingested directly from the large language model, because most of the, for example, GPT models are being trained on so massive data source that it has already this information in the model. Alternatively, regarding the weather, it wouldn't be so easy because, of course, the model is not being connected to the internet, so it can provide the information from the model itself. So what are the data sources in this case? So we have three data sources. One is database, the SQL database. The other are the documents, so the information about the sightseeing in several cities in Europe. And the third is Azure Maps. This is the Azure service which contains a lot of maps-related informations, among others also the weather history, current weather information, and weather forecasts. Of course, this kind of demo and this kind of information can be provided in something like tourist information, but it can be also used in different use cases. One of the examples that we have provided with, I would say, similar data sources was the chatbot for one of the bank, in which we have, of course, the documents from the bank about the policies, about the about all of the informations which are stored in the documents. But we also have connection to the transactional database, so it was possible to ask the questions to the bot about some customers' behavior and the policies of the bank. So one of the purpose was to provide as much information from this type of sources as possible. Regarding database, how it's working. So we have the question from the user, which can be in this case about what is the population of Warsaw. Then we have the LLM model, which translated, and first the LLM model decide that, okay, if we want to ask about the population, we have this type of information in database. So the next large language model is process this information and trying to prepare the query, which will ingest this information from database. Okay, so we should have the information. Okay, select population from the table where city is equal to Warsaw. Then we send this query to SQL, and the information from SQL database is being processed by second large language model, which prepare the answer for the user. For instance, the population of Warsaw is 1.6 million people. In my demo, the SQL database is very simple. It contains only one table with 5 columns like city, latitude, longitude, country, and population. The next data sources which I mentioned was the documents. So we have the for instance, documents from Warsaw City Tours Guide, where we have the museums, the attractions, which can be visited during stay in Warsaw. The most important thing regarding the documents, especially from the costing perspective, is how the documents will be split. Because the current models, for instance, GPT-4o, is able to handle at once approximately 200 pages of text. So we can easily put this 200 pages book into the model, and it will answer us the question based on the whole context. But as you may know, and the large language models are, in most cases, the cost for large language model is calculated based on used tokens. So if we'll use 200 pages to prepare one answer, this answer can be, for instance, a few dollars. So this chatbot, in most cases, would be rather economically inefficient. So it's very important to split this information and provide only the pages that are most relevant for the answer. So if we are working on the documents of the museums, we want to just see the page on which the museum, or pages on which the museums from Warsaw are being presented, and not, for instance, information about cafes, about restaurants, and so on and so on. And the last data source, as I mentioned, was the Azure Maps. This is the classical API in which we have, which we can provide the duration. So how long from today we want to have the forecast, whether we want to have the forecast for tomorrow or in 5 days or in 10 days and so on. It can be even forecast for 45 days. So like what will be the weather in 1.5 months, but I don't think that in Warsaw it would be very accurate to predict which will be the weather in 45 days. Of course, we can also provide other parameters like language, like format, which we wanted to provide it, and so on. Okay, so let's move to the demo and to the monitoring. Okay, can you see my screen? Yeah. Okay, this is all on the screen. Okay, so let's ask some questions, for instance, about the weather in Warsaw. Okay, yeah, as you may see, we have the information on the current, about the current weather. So this is weather for today. About the range of temperature, I think it's quite relevant. About the hour of sun, about the wind speed, and so on. And we can also provide our feedback about how we like this answer. We can also ask about the what can I visit in Warsaw? I see I made a mistake, but we will see how will be the answer, even with the mistake. Yeah, so this one letter wasn't something which was problematic for the large language model. And we have the several sightseeing that can be visited in Warsaw. And maybe we can also ask about Barcelona. And how about Barcelona? We will see whether it will take also the history, which we conducted earlier, because of course here is the question about it also gained the information that we wanted to know about the Barcelona's sightseeing. Okay, so let's move to Langsmith to see what was underneath. As you may see, yeah, there is several other information, several other queries that I have tested earlier. So regarding the information that we have here, of course, we have each of the question that has been provided. Okay. We have the information about the total tokens associated with also cost of these tokens. We have the error rate. As you may see, yeah, there was one error in the history. So we have the error rate at 8%. We have one user feedback which has been provided. And how many runs we had, so how many questions the user provided. Okay, so let's start with the question that we put here. So we asked about the weather in Warsaw. We have all information about the history which has been inserted. So of course this is part which has to be programmatically implemented, that we want to load the whole history from the previous messages. That's why when we asked about how about Barcelona, they knew that we wanted to ask about the sightseeing, because otherwise it wouldn't be possible. Okay. And then we have the GPT-4o model with three functions and tools. We have get from knowledge base, get from SQL database, and get from API, which has been called. Why? Because in the system message, we have the information that this assistant helps users with planning trips to European cities. We have the information that we have all of the available tools. And of course, it is possible also that you may not need to use the tools for every query, because the user may only want to chat. So don't want to being provided with the information from the tools. So we have then get from knowledge base. This is the tool. So it can be also called as function in Python. So we have the in documentation that this specific function is useful when you need specific information about city in Europe, interesting activities and places, tours, attractions, sightseeing plans, etc. from the knowledge base. So the model will know that if we want the information about the sightseeing, it should call this get from knowledge base function. We have also get from SQL database, and we provided information that this function is useful when we need the information about geographical coordinates, about the population or the country in which the city is being located. And the last is get from API, and this one was called because it's useful when you need the information about the weather in the European cities. So that's why we ask about what is the weather in Warsaw. The function get from API has been called. And in this we have the whole structure of this function. We wanted to call the SQL agent executor because we had to being provided with the information about latitude, longitude, which are the input for the Azure Maps API. Which is also important. We have for each step and each sub-step, we have the information about the time of processing. So we can easily check how long the specific step took and whether we can optimize it some way. This is, by the way, something that I will show as one of the challenge. And if we have all of this being provided, we have the rendered output, which used 18,000 tokens, and it took of almost 14 seconds to provide the answer. Yeah, and here we had the question about visiting in Warsaw. So what is interesting, we didn't need to provide, we didn't need to call the function which was get from knowledge base, because the question about Warsaw was previously provided in the history. So that's why the whole history has been here created. And as we can see, it took 9 seconds for providing the answer and took almost 10,000 tokens. Okay, let me return to the presentation. Okay, so what are main challenges in this kind of solutions? These questions were not so complicated, so it didn't take so much time to provide the answer, but it still was between 10 to 15 seconds. This time is especially crucial when we have this some kind of information from database, which much more complex model. It sometimes can take even minutes because of the query which has been generated. And what is also important that sometimes, of course, the first query isn't the ideal one, and it still needs to some improvement. So in some cases, we need, for instance, 2 agents, which one is providing the query, and the second one is checking whether the query is okay or it should be improved. So it also prolonged this time of providing the answer. The second challenge is, of course, the famous hallucination of large language model, which, by the way, is I would say not a bug, but the feature of the LLMs. As in most LLMs, they provide this answer based on the statistics. So sometimes they randomly choose something which is, I would say, 1% of probability. That's why this is sometimes called hallucination, but in reality it's not. So this is something which can be challenging when we have especially also database information or some document information, and we want to have the as much accurate as possible answer to the user. And last but not least is the challenge of also mostly related to databases. With this example, what is the population of Bratislava? Okay, the population is approximately 432,000. And I don't like this answer. Please remove Bratislava from the table. So based on this query from the user, the query remove from table where city is equal to Bratislava can be provided. So it's very important that the permissions of the bot, of the agent, would be as much as the same as has the user, which is using this agent. And in most cases, it should be the least permission that is possible, like read permission to the database. So this kind of queries wouldn't be able to provide it. Of course, in some cases, maybe we want to have a more automated way of for example, SQL development, and we want to provide it higher permission, but it's rather rarely situation. Okay, that was all from my side. If you are interested also in seeing more details about this solution, I will be speaking in Bydgoszcz at SQL Day Light. I will conduct a workshop in which we will go through this solution from the beginning. We will create this solution from scratch. So if you are interested, I invite you. And thank you very much for attention. If you want to stay connected, feel free to join me on LinkedIn. And if you have any questions, feel free to ask.
Okay, thank you, Paweł, so much. Big applause. Do you have any question? Okay.
Hi, I have one question. Did you try to use AI search instead of querying database from the model?
I didn't hear.
Did you try to use AI search in this solution?
AI search? Yes, this is part of the solution for the documents. So the index has been built based on the documents, and AI search is one of the part of the architecture.
Okay. Any more questions?
So I don't know if I understood well, but if the AI pick the function which needs to be used for for example, weather or coordinates retrieval?
Yes. This is how the agent is working.
Okay, so you don't have to provide some if-else's. It is picked by the AI.
No, this is only this information that we have in the Python function documents. Yeah, so we have the information that this specific function is useful when you have to answer about the weather. Yeah, and based on this information and based on the user query, which was what is the weather in Warsaw, it can combine it automatically. So you don't have to put it if the question is what is current weather or provide any of topic. It can be found semantically.
Okay, thank you.
Okay, thank you. Are there any more questions? Okay, if not, so please welcome Paweł on the stage, who will give Paweł some statue.
Thank
Big
you much.
applause, yeah.